Bruh. Hello everyone. Finally, welcome back. It's Friday. Yeah, sorry for missing out streams. Well, stream up on stream. I finally got back my, well, not my connection, but a decent enough connection. I thought the problem resided with my ISP, which is actually only part correct. My ISP has issues with their fiber hub somewhere, and the end result was that the connection was kind of wonky for a while. But the main problem was that my Ethernet over power adapter is kind of bonked at the moment. So I'm getting less than half the bandwidth. I don't know if it's because of noise on the line or if it's just that the adapter has just broken down. So as soon as I do anything more complicated than, I don't know, not even browsing the web, because that is kind of broken down anyway, probably chat, the bandwidth at my disposal goes from a megabyte per second to basically zero. It's just broken. So I tried streaming, what was that? Last week, and it was a disaster. And now I'm actually getting something decent out of it because I switched to Wi-Fi. Or at the very least I switched my desktop to Wi-Fi adapter, and finding one that works on Linux is actually the most complicated thing I've ever done. I had to hunt down a wiki page that lists all the supported Wi-Fi adapter chipsets. Then I managed to buy one, except the model name was different by one letter, and the end result was that the chipset was completely different. So I spent money for nothing. So I had to buy another one, and that one took a week to get here. Yeah, finally I managed to get something that is good enough, to the point where I'm actually using the entirety of the bandwidth that was promised to me. Of course, the issue now is that I'm paying a lot of money to get not a really great internet connection, and it's also still wonky a little bit on my ISP side. So next month I should get a new ISP, and hopefully I will put all of this behind me. It is so annoying. It has gotten worse over the years. So I moved into this house 6 years ago, and the network connection was not great, but decent enough. And over the years, the available bandwidth has been slowly deteriorating. And considering the amount of money I'm spending on it, no, doesn't work. No. Anyway, luckily, now I actually have an internet connection that supports me streaming, so I can actually do this. It's also getting warmer and warmer in London, so, well, depends. It has gotten warmer, then it was incredibly wet, and now it's warm again. So, hi, Chip Will. And yeah, it's a happy Friday after all. Oh, God. But yeah, to celebrate this, I wanted to do something that has been requested a couple of times here on the stream, but mostly on other media, like on chat or on social media or issue reports or whatever. And it is kind of a deep dive inside GObject. Because apparently the fact that the documentation isn't super clear, and the fact that the code isn't super clear hasn't deterred enough people to not try and understand how GObject works. People are still trying to do that, which is unclear to me. They should just be using the API instead of trying to understand how it works. But yeah, so basically, yeah, I wanted to spend some time like outlining how this thing that sits at the center of the entire GNOME platform actually works, and why it works that way, and what it does, and some of the subtleties that enter into it. Not because it's super complicated. In actuality, if you know enough C to understand how to use the API, then you probably understand how the API is implemented. It's just that over the years, we added a bunch of utilities and a bunch of convenience around it that shields the younger minds from the awfulness that is the entire thing, and that introduces some sort of challenge. People are more interested in peeking behind the curtains of the entire thing, and I don't understand why. I mean, I understand why. I used to do the same thing, but honestly, it doesn't really matter. But yeah, if you're interested in understanding why GObject and how GObject, then this stream is probably for you. Even if you already know GObject, maybe this stream is for you. Mostly, well, probably to just point out how wrong I am. But if you want to have fun, then I cannot prevent you from having fun at my expenses. So feel free to join and say how wrong am I. But yeah, so yeah, I think we probably want to start a little bit with the history of this. Mostly because this thing that we call GObject, and we used to call GTK object, and so on and so forth, is it hasn't changed that much over the years. There are some changes here and there, but it mostly stayed the exact same as it was when it was implemented in 1997. And most of the, well, not most, but a lot of the design came from early, well, sorry, no, it was 1999. 1997 was the original idea of a type system in C for the use of GTK. It was even earlier than that, probably 1996, because GIMP was 1995, 1996, and in 1995 was still using motif. So yeah. But yeah, the point I'm trying to make is that this thing is old, and it's really old. It predates the C99 ISO standard. It predates C++ as a like formalized standard as well. If we consider like the first like true specification, the C++ 11. So this thing is old, and some of the decisions that were made at the time made complete sense in the framework of, well, in the frame of reference of, we are trying to write something that is not C++, but it has to be compatible with the technology that we had at the time. The fact that it survived until 2022 is a testament to the fact that we are stubborn as hell. And part to the fact that the design is not that bad. I'm desperate for a better understanding of some terminology. Yeah, I'm part of what I'm trying to do is give people the terminology and the basics of this functionality so that you can ask better questions, but also you can find the answers in the code yourself if need be. Hi, flying by monster. It's older than you. Yeah, it's. Oh my god. Oh, I'm crumbling to dust. Oh my god. Yeah, I feel myself crumbling into dust. But yeah, basically, so this goes way back. Back when GIMP was first started, it used motif, which is an older toolkit for the Unix desktop, so to speak. And it used motif because the people that made GIMP were university students, and they had access to like Unix and motif because of the university. But if you want to redistribute an application built on top of motif, you have to pay a license. You had to pay a license. These days it's open source, but at the time it was not open source, and you had to pay a license to get motif applications, to distribute the motif applications, which didn't really gel with the fact that GIMP was released under the GNU copyleft license. So the people that made GIMP decided, well, let's take it and rewrite the toolkit for our image manipulation program. And they decided to write the GIMP toolkit, GTK. At the very, very beginning, GTK was closer, well, the GTK type system was closer to the GL type system. So every single object was determined by an integer value. So you allocated a GTK button, for instance, and you got back not a pointer, but unsigned int that you would then use for other things. There was no inheritance, so everything was a flat hierarchy. So you can create your own GTK buttons for plugins and stuff, which meant that the entire thing had to move to a different description of object orientation, not a flat hierarchy, but something that could be nested. You could have subclass, well, derived types of widgets inside GTK. Fun fact, motif is still maintaining rel. Yeah, I know. Carlos Soriano used the former Nautilus maintainer used to maintain it for his past sins. because a lot of commercial applications that date back to the 90s and early aughts are still written in Motif. And usually those are business critical to the point that companies and institutions will pay a lot of money to maintain them, to keep them working until at some point they will fall apart. So if you ever wondered, oh, now that COBOL is getting replaced, what can I get into so that I will get paid obscene amount of money to do maintenance and not care about anything at all? Motif is a good choice. It's a strong contender as the next COBOL. But yeah, so where were we? We are around 1996 at this point. So 1996, GTK is still inside GIMP, but has a type system that you can actually use to create a hierarchy of objects. 1997, GTK gets split up. Well, late 1996, early 1997, GTK gets split off from the GIMP repository, becomes its own project. And I think, if I remember correctly, it was midway through 1997 that GTK 1.0 gets released. At the time, GTK has added inside itself a copy of glib, which is a small library at the time. It was a small library that implemented a bunch of useful types for C, like lists and hash tables and stuff like that. And it gave some, I'm not going to say portability because it wasn't really portable. It was portable across the Unisys at the time. It wasn't portable across anything else. But yeah, mid 1997, GTK is out of GIMP and its own project. 1.0 is almost out. 1997 August, the GNOME project gets announced and the thing takes off from there. So we are at the very, very, very beginning of the GNOME project and GTK. So we have a type system there that is part of the toolkit. The concepts at the base of the type system haven't changed at all in the past 25 years. They work in a very simple way. So in order to understand how GObject works, we need to first look at how you can do type systems and object orientation in C. So yeah, let's start with a very, very simple example. Okay, so this is a simple project that I created. It's empty, doesn't do anything, but I wanted to give an example, so I'll need some source code and stuff like that. So let's start. So we'll start with a simple file, sample op. So how do you do object orientation in C? There are various ways. There are many ways, but there are various ways. And it mostly depends on the context in which you're in. Especially, well, more than the context is the nature of the type system you're trying to express. So let's say you have a flat hierarchy. You have a single type, an initial type like base, and then you have type A, then you have type B, and then you have type C. So nothing complex like nested like hierarchies or like deep inheritance of types. You have a base type, and you have like 3 types that inherit directly from the base. The simplest way you can do this is to use a discriminated union. Now, this is a like weird like science fiction thing, but it's actually really like trivial. C has 2 structured types. The first one is the one that we all love, the struct type. And we'll use it. The stupidest thing you can do is point, and then you do float x and y, and you have a point. Done. The other structure type that C has is it's used less often, especially by newcomers to the language, but it's the union. So it's another structure type that has an interesting characteristic. Let's say it will define the it's defined as a structure type that contains other types and has a size that is the largest possible field inside its own union. So let's say and then we can, well, sorry, no, call it value, and then we'll call it int long double deep double. So whenever you create a value, an instance of the value union, you create a type that is as big as it can, in order to contain the largest element inside the union. For instance, on 64-bit architectures, both double and char are going to be 64-bit because this is a pointer. So it means that the union value is as big as a double or a char pointer. On 32-bit is going to be a double instead, because a pointer is going to be 32 bits. So how do you use unions to do types? Well, I think the most adventurous among you probably have understood already where I'm trying to go, but let's say we have typedef struct base, then we get like def struct and then we have like def struct bubble yo type b, then we have typed of struct let's say int let's see. So we have these 4 structures here, and then we create a union and we call it base type A type, oh god, I'm terrible at typing. Type B. There we go. Now we have, every time we create an instance of an object here, we are actually creating a union with with one of these types here. Right now, how do we design? I would define which one it is. So how does it work? Well, the simplest thing to do is to actually define okay, so it's going to be base type, type A, type B, type C, and we call it type, and there we go. This is incorrect, by the way. So why? Let's try and go through it like one thing at a time, so we can understand how it works in the future, because we are going to use something similar for when we explain how GObject works. Well, how the next type of object orientation technique works in C. But basically, what a union does is it creates an area in memory that is as big as the biggest one of its members here. And then when you read it, so if you do something like O equals size of object, and then you do O type A str, you can do like printf, what this does to the compiler, well, the compiler will tell, okay, there is a type A field inside the structure, inside the object union, and I will access the string, the str field inside the structure. And this is perfectly fine, even though we haven't initialized anything of this, because a union lets you access each and every type of each and every member of the field that you want. This allows you to do really nasty things. For instance, you want to see let's say some, yeah, you want to see how sorry, so you want to see what is the representation of a floating point value as an unsigned integer. This is how you do it. You do val float f equals 42.1, and then you do printf and you do this, because this is the important thing. Whenever you write to a union, you're actually writing to the entire union. And when you read it, you're reading the entire union again. It's a single value. So even if you write to the float field inside the union, and you read the unsigned integer field from the same union, you're accessing the exact same data. This is called type punning, by the way. And yeah, it's C is terrible in all the way that makes it useful, but it's still terrible. Hi, Jakub. So how do we actually, so you can do this, but also you could do let's see, this. So how do you distinguish the two cases? How do you distinguish the fact that this object is actually a type A or a type C, right? So this is what a discriminated union is. You store the type inside the base type here, and every other structure has to have the exact same layout as the base type. Because then, instead of doing this, you could do switch base type, and then do case type A, and then here you can do O base type A, and then type A str equals there you go. So the way it works is basically you are overriding the memory layout. So if you only access the base like this, then you can access the base field here. But then you can also say, I want this to be type B, and then you define the type, and then you store the value here. So this is very, very rough. This is how unions work, discriminated unions work in C. It's just you define an object here that contains all the possible types and the base type here. And then you define all the possible types as matching the base type. So if at some point I decide to do a ball allocated, something like that, then I have to change every single type so that they match. Because the memory has to match, the memory layout has to match, so you can access the basic value there. Otherwise, you wouldn't be able to access the type. If I moved this here, and then I did this on type B, for instance, or type B instance, then I would be writing to the double field whenever I do base type. Because I'm accessing the memory, I'm not accessing an actual object. I'm accessing like a blank space, and I impose on that blank space whatever I want to. Again, C is terrible. So this, the using unions, using the trick of using unions for object orientation is fine if you only have a well-known hierarchy of types. If you are planning to only allow this kind of type system. So a single base and then a single base type, and then all the other types derive directly from the base type. And of course, if you can change the size here, if you can change the fields here, then it's perfectly fine. For instance, if you are familiar already with GTK 3, this is how GTK event is implemented. GTK event is written like this. It's a union of a bunch of different structures, and depending on the event type, then you can access the different fields inside the union. Let me see if I can get open project, select folder, I don't have it, GTK here, I have, let's see, GTK 3. So GTK events here. So you see we have GTK event that has a bunch of different structures there, and the union GTK event here. Then we have the GTK event type, and then we have all the various structures, and the base structure is GTK event any. Any event will have these three fields: type, window, and send event, and they have these three fields at the very top of their structure. So GTK event expose has these three types, these three fields. GTK event visibility, same thing. Motion, same thing, and so on and so forth. And then we have GTK event as a union as GTK event any. It also has GTK event type as the first field because this is easier, so you can do event like arrow type, but the memory layout is going to be exactly the same. So this is actually just a shortcut to event any dot type. Yeah, if you want to understand more about this technique, I strongly suggest you look at any C tutorial about type punning, P-U-N-N-I-N-G, type punning. So we have this way of doing object orientation. But what happens if I want to do something like this? So I want type B to inherit from type A and type C to inherit from type B. The solution to this is already included in the previous example. So the union type punning is already kind of giving us a way to implement this. So we have struct base, and we like define it as, I don't know, type here. Now we want to have type A to be the same as type as the base structure, but also want to add our own stuff to it. So the way we did it before was type A, and then we need to have type here, and then let's see, str. So what happens is that if we instead of doing this, we do this. When we allocate a type A structure, we are actually allocating also a struct base structure, because this one will be expanded to fit into this this. So this is how you implement inheritance in C. B, do type A, and then you do C, and because then this one will expand to be struct, and so on and so forth. So this is the basic trick. We are telling the compiler, hey, allocate like type C, and type C will be containing everything that includes type B, which is going to be everything that includes type A, which is everything that includes the base. But how do I access it? How do I pass a pointer to stuff? And then, how do I pass a pointer of type C to a function that expects type A or base? Again, C is terrible, and it's terrible in all the way that allows us to do nasty things, which also includes implementing object orientation. Because whenever you pass a pointer to something, you're just passing an address of an address in your memory, right? And what that address in memory is can be whatever you want, as long as you don't read before that point, the point in the memory, or after, like the size of that allocation. You're golden. You can do whatever you want. So if you allocate like this, and you do raise off type C, then you could do base, and do this, and you're perfectly safe. It's perfectly fine. Doesn't do anything special. You're just telling the compiler, hey, this pointer to a bunch of memory, you should just cast it to a base. So I want to only read the type field of the base structure. And again, it's perfectly fine, because type C is going to be bigger than base, because type C includes type B, which is going to be bigger than type A, which is going to be bigger than base. Greater than or equal. So you could define a type A like this, and it would be perfectly fine. So you're getting a bunch of memory, and then you're reading into it. And it doesn't matter if that memory is defined to hold a structure type C. As long as it's bigger than base, you're fine. Of course, say now you do something like this, and you're basically screwed, because What happens now? Who knows? Everything falls apart because this is C and the compiler will not save you. So you cannot, this is why you cannot count on compile time checks when you're using GObject. You can only count on compile time checks for a very specific set of functionality, but otherwise you're basically on your own. Everything is done at runtime. Because the entire thing is based on is predicated on the idea that you are not passing actual structures around of a certain type. You're passing around pointers to a certain type, and that type can be modified or can be bigger. It cannot be smaller, but it can be bigger, it can be different. So all of the type checking is done at runtime when you're doing this. This is what all the argument validation, type validation in GObject does, and GTK does, and everything else. It has to do all this type of stuff at runtime. Not just because the types are registered at runtime, we'll see what that means later, but mostly because you're not passing around actual objects, you're just passing around chunks of memory, and you have no idea what that memory actually contains until you look at it. And it is safe to look at the first few bytes, which is why all the type information is at the very beginning of any structure. And if it doesn't, you get a segmentation fault and you're on your way. So this is what happens. And underneath it all is this mechanism of doing object orientation in C. It's the very base of the GObject like type system. You have nested structures, and you always have a structure that contains the parent structure as the first field. Okay. And we kind of hidden all of this behind a bunch of macros that deal with this for you and shield your eyes from all this mess, but it is basically that. There's nothing more complicated beneath it. You get a bunch of memory, you allocate it, and you say, this is going to be a GTK button. Then you take that GTK button, you pass it around to stuff that expects a GTK widget. In which case the API will say, you gave me this like bunch of memory. I will read the parts of it that I know are big as GTK widget. If this is really a GTK widget, then it's going to be fine. If it's not, then everything will crash and you will be forced to use GDB to actually debug the entire thing. There is no help from the type system, like the compiler. There's no help from anything else. It's all at runtime and possibly might crash. Which is why you should be using other languages other than C. But this is, yeah, let's not let's not focus on that. So this is how the object orientation works in GObject. Why do we need a lot more API on top of that? Well, the reason why we need a whole lot of API on top, like, let me see if I can get you open a project, folder. So if we go into glib and we go into GObject here, we have a type system, the type system API, and this is a lot of API. Why do we need all this API to deal with object orientation in C? I mean, there's a lot of stuff here. Even if we don't go into the weeds of macros and stuff, so we can ignore the macros for the time being. But this is a lot of API. Why do we need this? The basic reason is we need this for reflection purposes. So we could all use an enumeration, like we could all say, oh, it's an enumeration value or a string or whatever to discriminate between types. But that information doesn't give us anything, really. It doesn't tell us at runtime, this object that you just gave me is a GTK button, which is a GTK widget, which also implements the GTK buildable interface, and it's also a GObject. And all of this information is actually required, because otherwise we could not debug the code that we have. We could not understand if you're passing the wrong object to the wrong function. You could not do things like language bindings on top. So all of this API is mostly reflection. It's mostly introspection, a way to query a lump of memory and see, okay, you are a GTK button. What can you do? This is what you can do. And it all starts from a very simple entry point, which is, where are you? Which is this. Well, gtype register static, but we're going to look at GTK type register static simple, really, because gtype register static is just static simple is just the same call, but it will fill out a type info structure, which is a way to describe all of this anyway. So what you're doing is you're registering a type. You're telling the type system, hey, this is a new type. This is a type that I'm registering it. So I'm going to pass it the parent type here. So for instance, I'm registering GTK button. GTK button as parent type GTK widget. This is the human readable name as a string. This is the size of the class, and this is the class initialization function. We'll see later what happens. This is the size of the instance, and this is the instance initialization function. And these are the flags for stuff like this is an abstract type, this is a final type. So I'm registering a type inside the type system, and I'm getting back a value. This value is not important right now. Suffice you to know, this is a numerical value, and you can pass it around, copy it, do whatever you want with it as a read-only thing. You cannot compare it to anything. Well, you cannot have a comparison relationship, an order, like you cannot order G types. There's no point in doing that. But basically, you can store it. You can copy around. You can copy it around and stuff like that. So you need this metadata, this information here, like the class size and the instance size, because when you're instantiating a new instance of this type, the instantiation will be done for you. You will not call like malloc yourself. You cannot do that. So you need to know, the type system needs to know how big it is, how big the object instance is, and how big the class is. And then it will call a function for you when you need to initialize the memory of the class and the memory of the instance. That's it. So again, let's go back a little bit and try to figure out what a class really actually is. So right now we've seen struct, button, so this is our GTK button, right? It's a GTK widget here, and if we look back at what GTK widget is, then we go this, and it's going to be a GObject. Well, yeah, it's going to be a GObject. But what is a GObject really? It's actually a G-type instance. So it's this type here is provided by GObject itself, libGObject itself, and it mostly means this is an instance of a type. This is the base of our type hierarchy. It's not GObject. GObject is not the base. G-type instance is the base. But GObject is where we start usually, because it's where things like reference counting is implemented, where weak reference is implemented, where signals and properties are implemented. Again, not entirely true. I'm taking massive liberties here. But for the purpose of this point, at this point in time of this deep dive, GObject is where our hierarchy starts. G-type instance is the man behind the curtain. But it's not really important right now. So for the time being, let's consider GObject as our base. So outside of the instance, you also have, if you've seen GTK widget code already, or yeah, if you haven't seen it, then you can take it as an article of faith at this point. But we're going to experiment what it is. I'm going to explain what it does. But aside from an instance structure, you also have a class structure. So which follows the exact same rules as the instance structure. Again, no. And here again, GObject class. No. It's going to be. So why two structures here? Why do we have an instance and a class structures? The main reason is that you have stuff that is associated with the type, and you have stuff that is associated with the instance. So you have a button instance like this, but you also have things that are shared across all button instances, like virtual functions, like signals, like properties, like style, like whatever. It's not something that is part of the instance. It's part that is shared across all instances of the same type. And that information that is shared across all instances is stored on the class structure. Again, this is needed because of things like properties, signals, other information, like inside GTK, for instance, we store the, for instance, the layer manager type or the CSS name for styling purposes, the accessibility role, because you want to ensure that every single instance of GTK button or every derived type will have the exact same information if GTK check button inherited from GTK button. And the way these two things are connected, the way the button class and a button instance are connected, is through gtype instance and gtype class here. Because gtype instance is just a pointer to the class. So whenever you create a gtype instance, it gets initialized to the class vtable, and every single instance of GTK button here will have a pointer to the GTK button class as the first field inside its own structure. So it will literally be something like this. Which means that from a button, you can always, a button instance, you can always get the button class structure here. And this is what macros like GTK button get class really does. This macro, if it's a macro, otherwise if it's a static inline function, if you're using the new gdeclare like macros, what they do is literally just cast away everything and get to the first field of the structure, so it will be the class pointer. Again, we do this stuff like GTK button get class because it's easier to deal with this. What it expands to is pretty much this. Instance. There you go. That's all it does. And that is also the same thing as widget. Here it's going to be GTK widget. All it does is widget equals a. This is the point of all these macros here. they just remove, they just make this stuff readable for you. And in debugging builds, they will also do a type check. So they will literally do something like something stupid like this. API type plus. I need to expand this from memory, so forgive me if I get it, if I don't get it right instantaneously. So instead of having all of this stuff, it's terrible to read. And it's also not entirely correct. But it's not entirely correct. It's correct for what it does. It's if you're dealing with things like, I want to check if this here is actually like button here, and GTK buildable is a G-type interface, then this like equality check is not going to work because interfaces are different. So, but again, this is like, I'm getting ahead of myself here, but I want to explain that the magic macros that you see everywhere are just a way to avoid having to deal with expanding everything manually, doing type checks at runtime in debug builds, and so on and so forth. But they don't do anything special. They don't do any magic beyond casting stuff and accessing fields. There is no deep black magic at work here. Everything is very plain. Everything is complicated, yes, but conceptually it's fairly simple to understand. You just need to expand this all in your head most of the time. Okay. So we have an instance structure and a class structure, right? So we have a class structure that is tied to the instance structure, and then we have the instance structure there that deals with all of this stuff. Where are you? So when do we call this register static here? The where are you? I lost you again. Here. So when do we call this? When do we call G-type register static simple? And why do we call it? And how does it work in behind the scenes? You've probably seen it like a bajillion times. You probably also have seen, so you would have seen this a lot more if you were writing GObject code like 10-15 years ago, when we didn't have as many macros as we do now have, because at the time you had to do something like this. Awesome widget type you simple type widget awesome widget, and then you would do size of awesome widget class. This is 0. And this. So let's assume you have a new type. You have a new type, then you want to say, okay, I am going to give you a type registration function, which is my awesome widget get type. So I can construct new instances of this type and so on and so forth. I can inherit from this type. But how does it relate to the rest of my code? Well, the rest of your code can do something like this. And then if you have another type, then you can do type other, then structs. And there you go. And then this. So this is the reason why you have the getType function and the type macro. The type macro is just hiding the fact that you're calling the getType function, and the getType function registers the type. And if you try to register it multiple times, then it will fail, because of course it will do, but this is how it essentially works. So you're actually registering the type every time, well, not every time, the first time you call the type function. The same happens with GTK type widget, GTK type button, GTK type whatever. It always works the same way. You have a get type function, the get type function registers the type the first time you call it, and then returns the type you just registered. So you can use the type inside your own code. And the registration just says, this is my class, this is the size of my class, this is the function that you have to call whenever you instantiate a class. Well, whenever you instantiate the class for the first time. And this is my instance size, and this is the function that you have to call every time you instantiate a new instance of that type. And that's it. You should never do this anymore. This stuff is handled for you by the new macros, and it's handled for you in a way that it will not make a mess. For instance, in this case, we are always trying to register the type. this is wrong. You cannot register the same type multiple times. So in theory, you should do something like this. Type valid, and then if type not equals G type invalid, oh, come on. That's it. Now you can call it multiple times, because only the first time will register the type. Except now it's not thread safe. So multiple threads can try to register the same time at the same type at the same time. So instead of doing this, you should be using this. If G wants enter, wants init enter type, and then do lodge view this, and then he wants leave. Sorry, this is going to be G type. And now it is thread safe, except that it's a very hot path, so you probably want to move it somewhere else, and so on and so forth. It's complicated, yeah, and it's very prone to mistakes, and it's very prone to performance issues. So instead of doing all of this, you should really be doing this. And this goes away. This macro here will define the getType function for you, and it will define everything based on best practices. It will be thread safe, it will be, hopefully, it will perform well. It requires some basic adherence to the conventions of GObject, but those conventions are easy to adhere to because they're well defined, and not only they're well defined, they're also the result of the past 20 years. So it's a lot harder to go against the grain when everything follows the same kind of patterns, and has been long before the introduction of this macro here. Because calling your macro here, GObject, right, instance, and calling it the class using the same name with class at the end is not weird. It's what people have been doing for a long time. So saying that, okay, if you use gDefine type, then your instance should be called this way, and your class should be the exact same thing but with class at the end. It's not weird. It's how people have been using this code for the past 20-ish years. So you wouldn't call it like my awesome widget and then call it like bar class. It would be like, what the hell are you doing? But yeah, basically this is how the gDefine type macro works. It defines the getType function for you. and it defines the getType function for you in a way that is safe to use across threads, and it's safe to use multiple times. It's easy to add functionality to it. It's easy to derive new things from it. It saves time and effort, not just because it's a macro, but because it allows GObject, for instance, in the future to do more things inside the getType function than it does today, and you will not have to modify your code. So if some stuff changes, like we switch to GType register static simple 2 at some point, then the gdefine type macro will not have to change. We'll call GType register static simple 2. And we'll do it slightly differently, for instance, to improve the performance. We already did this at some point. GDefine type was modified so that the type registration was moved into a specific function that the compiler could optimize and not have a lot of contention with the lock around the type registration here. And if you don't implement your own getType function, you get all of this for free instead of having to change your code all the time. So, rule number 1, if there is a macro, please use it. And again, the macro hides some stuff from you, but the basic functionality is pretty trivial to guess. Let's drop this as well. And then we're going to move this here. So we're defining a new widget here, right? So we have the awesome widget type here and the struct here. And we have the type here. But we add also the class init and and the instance init functions. The gdefine type macro defines those functions for us because it will have to call them in order to register the type. If it didn't define them, then the macro would fail if you forgot some stuff, or it would not expand correctly. So what the gdefine type function does, outside of defining the gtype, the getType function is also defining let's start from this. Is also giving you the ability to define these two functions here. And these two functions will be called by the will be used by the type registration function, and this one will be called whenever we create the first instance of myAwesomeWidget, and this one, the myAwesomeWidget init, will be called every time we create a new instance of myAwesomeWidget. And for that, in order to explain that, I need to go a little bit deeper into GType. So taking a breather here, because now we are going into the abyss. And I've looked at the abyss for so long that I'm now become an abyss domain expert. And you don't want to become that. Hi, Scaru. Speaking of making stuff more convenient with those macros, as the pointer, I was wondering why Vala was more advertised as the first-class language for GObject. After all, it's sort of a macro compiled to C. that is complicated and it's its own topic. The main complication is you don't want the first class language for GObject. That is a very, very bad thing to do. You want more languages for GObject. You either want more languages that map to GObject, like the situation we have now, or you want to have, and I'm gonna sound like ungrateful, or I'm gonna sound unkind, but you don't want a language that is being developed by one person on their spare time with no formal definition and no tooling. And I say this not being unkind, I'm trying to be as like factual as possible. You want a language that is developed by a team of people that has, if not corporate backing, at the very least has the chance of not disappearing. You want a language that has tooling, you want a language that has some sort of roadmap with milestones and a way to extend the language, deal with deprecations, has a very consistent test suite, and so on and so forth. Basically, you want a proper language. Vala never became that. So it's not... It's really hard to convince people to drop whatever they are doing and go write a language. We have problems telling people we should concentrate on this particular area of the GNOME project. It's really hard. We're all volunteers here. And the fundamental tenet is that volunteer work is not fungible. You cannot tell volunteers what to work on. And we have a ton of volunteers that work on different languages. And the reason why GObject is written in C, the reason why GTK is written in C, the reason why most of our libraries are written in C is that C is, for better or worse, the lingua franca of our ecosystem. You can write translation layers that turn C into other languages and other languages into C. And Vala is not a macro compiled to C. Vala is a language. It has its own constructs, it has its own features at the language level that do not translate to concepts that are available in other languages, or if they are available in other languages, they do not exist at the library level. They definitely not exist at the type system level. So the end result is that you cannot use Vala to write code that is going to be loaded by a Python program. I mean, you can use a subset of Vala to write code that will be compiled to C, that will be introspectable and used by other languages through the introspection layer. That is fine. The other thing is you cannot tell people that code for C for a living to drop what they're doing in C and start using Vala. We can. The only way to make Vala the first class language for GObject would be to rewrite most of the stack in Vala. That is not going to happen. You're not going to rewrite GTK in Vala. Like, don't even try it. It's pointless. It's a pointless endeavor. You can write a new toolkit in Vala. You can write a new toolkit in Rust. You can write a new toolkit in Python if you want to, but it's not going to be GTK. And GTK is not going to be moved to another language. It's going to be easier to start from scratch and call it, like, I don't know, the GNOME, the general toolkit. meant for application development, but I get the lack of yeah. I mean, for application development, it's good. It's used by people writing the application, so it's fine. Again, telling people to only use Vala, no, that's not gonna happen. So, story time. In 2012, we told people, okay, we are going to concentrate on documenting stuff for JavaScript because GNOME Shell is written in JavaScript. And we have a bunch of applications that are currently written in JavaScript because the JavaScript bindings are up to date, fairly efficient already, and JavaScript is a well-known language. It's not a custom language for the GNOME project. So we can attract more JavaScript developers. It wasn't, at any point, it wasn't sold as, we are gonna stop writing applications in anything that is not JavaScript, and we are gonna tell everyone to use JavaScript to write GNOME applications. At no point in time that was the goal, or stated or otherwise, of the announcement, except everyone took it that way. Everyone read that and said, oh, GNOME wants to force everyone to use JavaScript to write their applications. JavaScript sucks and whatever. So the Python developers, the Python bindings developers, and the Python application developers got understandably angry, saying, what the hell? We're using Python. We've been using Python for 10 years now, and you're telling us, fuck off and use JavaScript. The other language bindings authors were like, what the hell? Why are we working on this on our projects then? And it took a lot of time to basically just say, no, we were talking about documentation. We are not talking about like applications or anything. We're talking about documentation. We want to concentrate on writing documentation, want to concentrate on getting like tests for the JavaScript bindings. But at that point, the damage was done. A lot of people were like legitimately angry at the GNOME project, and there's still a lot of ill will, if you pardon that. And a lot of people still think that GNOME wants to replace everything with JavaScript, which is utterly ridiculous. But yeah, that's why the GNOME project cannot at any point in time say, use this language. This is the language. Because this will never work. It didn't work before, it won't work again. The only language that we basically are mandating, up to a point, but the only language we're mandating is C for core libraries, because they have to be usable by different languages, and you can use them to write applications in different languages. For instance, we have a couple of libraries written in Vala. I would never recommend to write a library in Vala, because you are you're committing yourself to a very specific subset that doesn't really make any convenience available for you. And at that point, you might as well write in C, because at that point, yeah, you're just using Vala as a C language, and it's pointless. Vala is not a C language. We must stop fighting and all use C. Yeah, no, I wouldn't recommend using C for everything, but yeah, I understand the point. Oh. Right. Okay, it's been an hour, 40 minutes. I'm going to take a little bit of a break to make a call, and then I'll be back in like 2 minutes. I'll also get a refill of my coffee, because I will probably need it. To be honest, JavaScript was quite weird back then, pre-ES6. Yes, also high priority. The JavaScript at the time wasn't that great. It's improved a lot. but yeah, it's understandable that people took it the wrong way around, because it was communicated, to be honest, it was communicated badly. It was communicated at the tail end of a Hackfest, and the people at the Hackfest had all the context, but they were unable to explain it, were able to convey the meaning without also conveying the context. That is why there should be a blanket, like, it should be forbidden for anybody at a Hackfest to announce anything. You have to announce it after the Hackfest is done, after letting a bunch of people read it and comment on it, and then you announce it as a public thing. If you announce it at a Hackfest, you're gonna get everything wrong. It happened multiple times. It happened with GTK 4. It happened with GTK 3 even. So yeah, no. Never, ever, ever announce anything at the Hackfest. Always wait a week after that. If you can explain it to people without the context of the Hackfest, then you're golden. Otherwise, no. Anyway, yeah. Quick break, and then I'll be back like 2 minutes. Hello and welcome back. Oh, is it possible to use TypeScript with GJS? Yes, there are projects that have the type definitions. They generate them from the introspection data, so it's possible to use TypeScript. There's even an effort to make that possible to write GNOME shell extensions with TypeScript, as far as I know. Yeah, that's pretty much possible. I've never tried, so I'm not entirely. I'm just. Yeah, I don't speak from experience. I only speak because I've seen people do it. So where were we? Right, the instance in it and the class in it. So what do these functions do and how do they work? In order to understand that, we need to look at how objects are created. So we can start from the typical entry point. So let's assume you're writing your C code, you're writing your GObject, and you create your constructor. The C constructor is usually the lowercase name of your type in what is it called? Snake case. It's snake case type, and then new as the function name, and then you call GObject new because you're creating a GObject. You're instantiating a new GObject. So what does that entail? How does that work? So we will have to unpack that layer by layer. So you're calling GObject new, and you're passing the type of your widget. And as we've seen, what my type awesome widget does, it will register the type for the first time. If it's the first time, otherwise it will just return the registered type identifier of your type, and then null because we don't have any other argument for it. So what does GObject new do? The first thing it does is it will try to grab the class of your type, and in order to do that, we'll call something that is class ref. So gtype class ref is a function that tries to instantiate the class of the given type, and it will return the gtype class here with a reference to it. The other function that you might find inside user code, not inside GObject, is usually gtype class peak, which will do the same without returning a reference to you. So if you have never instantiated my type awesome widget, gtype class peak will return null. Whereas if you call gtype class ref, you will always get a gtype class pointer back. And this will call my awesome widget class in it. In reality, it will not just call that, it will call class in it for every single ancestor of my awesome widget class. So it will call GObject class init, then it will call GTK widget class init, and then we'll call my awesome widget class init. All in order. So GObject class init first, GTK widget class init after that, and my awesome widget class init last. This is needed because internally, what this entire thing will do is we'll create my awesome widget class, a pointer to this, and it will allocate. We'll use GNU because it's easier to visualize, because it's let's go with malloc. We'll do the equivalent of malloc type info class size. So it will allocate enough memory to hold my awesome widget class. And we know that my awesome widget class will also have enough room to contain GTK widget class, which will have enough room to contain GObject class. And then what will happen is we'll call this. It will initialize the GObject class part of the class, and then it will initialize the GTK widget class part of the class, and then will initialize the my awesome widget class of the class. This is needed so that the widget class init can reference the fact that this is really a widget class. So if I do widget class snapshot equals my awesome widget snapshot, I will override only the snapshot virtual function from the GTK widget class vtable. Everything else will be exactly the same as GTK widget class as initialized. What's the difference between widget class some signal custom function and call it gconnect signal with a widget instance? Okay, so as I said before, GTK my awesome widget class init will be called on the class, and the class is shared across all instances. So if I have awesome1 and then I have awesome2, awesome1 G class will be equals to awesome2 G class. So the exact same class structure will be used for all instances of the same type. So whenever you do something like this, the my awesome widget snapshot function will be called for any instance. The same function will be called for every instance of my awesome widget. And the same thing happens with signals. So if you define a signal and you define, for instance, let's say class as, I don't know, void select, something like this, and you do class click equals my awesome widget click, this function here will be called for every single invocation of the clicked virtual function. Whenever you do you can create a signal like, say, gsignal new, click, gtype from blah, well, it's my awesome widget. It's the same thing. And then blah 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 blah. I never remember the arguments there. It's fine. And then you do something like g struct offset class. Sorry, my awesome widget class. Okay. Blah blah blah. This one is just telling gsignal, please, whenever there is whenever I emit the click signal, this function here is going to be the function pointer at the offset inside my awesome widget class will be called as the signal class closure. We're going deep into signal territory here, and I'm not entirely sure we're gonna have time to talk about signals, but talking about signals is a whole other topic. But basically, the main difference between calling gsignal connect and overriding the virtual function in the class is that when you override the virtual function in the class, this function will be called for every single instance, whereas if you're using gsignal connect, that function will be called for that particular instance. Basically, this particular bit of code here is sets up your the class structure for every single instance. So if you call myAwesomeWidget new the first time, it will create an instance of the class and it will set up the class for everything. And then at the end, it will do my awesome widget instance will be the equivalent of malloc type info instance size, and then it will do the object init So this block here, the myAwesomeWidget class block, will be called the first time you create an instance. And instead, the myAwesomeWidget instance here, the block here, will be called every time you create an instance. So if the class has already been initialized, then it won't be called again. It will be called only the first time. Whereas the instance in it will be called every single time. It's the way we set up the instance in a neutral state. The initial state. Let's see here. We can call that something like this. So yeah, the basic functionality here is this one. Whenever you create a new instance, it will try to create the, it will see if the class has already been initialized. If it hasn't been initialized, it will initialize it by calling the class init of every single ancestor type of your type, and then calling the class init of your type. This way, you can rely on the fact that the virtual functions, for instance, all the fields on the structure that are part of your own structure, because GTK widget class is part of your structure, right? So all the fields will be set to their appropriate value. And then you can set your own fields there. And then when that finishes, we'll go into the instance initialization function. We'll create an instance here, and then we'll go through the instance initialization function for every single ancestor of your type, and then for your type. So you can rely on the fact that for instance, this, you can rely on the fact that this is valid. This will be called on a valid widget because it will be valid. GTK widget in it will have been called on this structure here. This is something you can rely on. Hopefully I'm making a little bit of sense here. I'm trying to reverse engineer knowledge from, yeah, almost 20 years ago. Hi, of course, Sandora. I liked your most recent blog relation. Oh, thank you very much. Yeah, I was supposed to blog about Amberol like ages ago, but I had to reset up my build after I upgraded my machine to Fedora 36. Sorry, I have to update my static blog generator after the update. So I basically procrastinated until it was not tenable to procrastinate any further. So I had to deal with that. Okay. So yeah, GObject new. GObject new does a little bit more than this. It's a little bit more complicated than this. It has more functionality than this. You don't only have the instance in it and the class in it. The instance in it and the class in it are concepts at the type system level. So they exist even for types that are not GObject. They exist for G-type instance class, G-type instance and G-type class, to the point that it's entirely possible to write an entirely different base object for your type hierarchy. GTK does that in a couple of places, like GTK event. It's not recommended, to be honest with you. I would not recommend it. We had to do it because of various concerns, but please, if you're writing like library code or if you're writing your own application in C, please use GObjects. Do not go into the G-type instance rabbit hole. I've written a blog about that, an entire blog post about that. Let me see if I can find it. Yeah, I wrote this like a couple of years ago. But yeah, basically, it also explains a little bit about inheriting types in C and how to make that work in GObject and Gtype and stuff like that. But yeah, the conclusion is still valid to this day. Please use GObject. Language bindings will work out of the box. A lot of stuff that people can take for granted, like weak references, toggle references, and a lot of other things exist at the GObject level. They do not exist at the type instance level. So, if at all possible, use GObject. Yeah, because how do I say this? Gtype instance doesn't do anything. Gtype instance is empty. It only deals with creating an instance that belongs to a class, and you can also tell it to basically allow deeper nested hierarchies. Other than that, Gtype instance doesn't do anything. Doesn't do like memory management, doesn't do reference counting, doesn't do anything else. It barely does signal handling. Well, you can install signals on a Gtype instance. You should never do that. Most of our code relies on the fact that signals happen on objects. They do not happen on random instances. So never do that. Properties, for instance, don't work on Gtype instance. You have to implement reference counting yourself on Gtype instance if you want to do reference counting. Otherwise, you have to do deep copies, at which point, like basically clones, at which point you're entirely on your own. So, word of advice, never ever touch Gtype instance. It's not a good plan. But yeah, once you start dealing with GObject, then GObject has a bunch of functionality that you probably want to use. Like, say, GObject properties. So, yeah, let's see. Okay, we have a pressed here. Okay. For that, we have to move to this here. Let's add this because otherwise, object H. Well, no, it's going to be GK. So, what are properties? Properties are not instance fields. So, whenever people start out with GObject, they will tend to put stuff into the instance structure and then put the instance structure in the public header file, like this. Well, no. We'll do something like this. Well, I can copy it. So something like this will happen, right? We declare the function here, and we define the instance and the class structure. Okay, that's fine. The main problem is, and this should be clear now that you understand how the inheritance chain works. The main problem is, if we have a field here and I decide to do something like this, what happens now? The myAwesomeWidget class, the myAwesomeWidget structure changes size, because now the size is going to have to include char name. The same thing will happen if I do this. Void fooBard. So now the size has changed, right? It's different. There is a new field. This field, in this case, is a function pointer, so it's going to be the size of a pointer. This one is the size of another pointer, so it's going to be like 64-bit more, and this one the same on a 64-bit architecture, and so on and so forth, right? But now imagine I have my other awesome widget that inherits from my awesome widget. What happens here? The size of this will change. If you are defining this inside your own structure, inside your own project, and nobody else can access it, then it's fine. Doesn't matter anyway, because you will recompile my other awesome widget at the same time as my awesome widget. Same thing, right? But imagine if you're writing a library. You're writing a library that allows people to derive from your awesome widget. And now you change the size of my awesome widget instance structure and the class structure. What happens then? What happens is that my awesome widget here, my other awesome widget, will have the size of the previous version of my awesome widget, not the new one, unless you recompile the other code that depends on my awesome widget. Adding a new field inside the structure here and inside the structure here is what it's called an ABI break. You broke the application binary interface. It means that everything that depends on your code will have to be recompiled against the new version of your library. And this is kind of fundamental. This is why things like GTK don't break the ABI interface. They will only add stuff and deprecate stuff, and why all the instance structures are hidden away into the source instead of being in the public. Or if they are, unless they are derivable, in which case they don't have any public field. All the public fields, all the fields for the instance structure are hidden inside the source code and not in the public header files. Because every time you change this, even if you add stuff, not even removing stuff, even if you add stuff, you have changed the binary interface that you're exposing to other people using your library. And this is inevitable. It's how the type system, how the inheritance is implemented. You cannot avoid it. There is no way around it. So the reason why we hide everything, the reason why we use macros like gdeclare derivable type and gdeclare final type inside our header files is because of this. It removes the ability for people to fuck up. Sorry. Oh, didn't move myself. Macros are there to eliminate the chance of fucking things up. Not just because of convenience, not just because it allows us to improve the code, but mostly, and this is fundamental, it removes an avenue for fucking things up. So instead of doing all of this again, you can do and it will get rid of all of this. But what it does, what does this macro do? Outside of defining a bunch of stuff here. What it does is essentially, since this is a derivable type, it will create this exact structure here. No public fields, nothing like that. It will only create a structure that has the same exact size as the parent type. And sorry, the macro doesn't delete everything, doesn't delete the class because it's a derivable type. So what it does is this. It leaves you with this. But of course, the main issue here is that it will create an instance structure for you that has the same size of the parent size, but since it's derivable type, you're supposed to provide your own class structure, because derivable types are used to do things like signal handlers or like other virtual functions inside your class structure and so on and so forth. So how do I avoid ABI breaks whenever I decide to add a new virtual function to the class structure? The things that we do for C. If you want to keep enough room for adding new virtual functions here, you can do something like this. Virtual functions are function pointers. Virtual functions are function pointers in C. Function pointers are pointers. This is not strictly speaking true at the spec level, but it's kind of undefined behavior, but we basically just require it from your toolchain. So if you're writing C on a platform for which the function pointers and pointers cannot be don't have an equivalence between them, then I'm sorry, you cannot use glib. You cannot use any of this. You cannot use anything. You can only use C89 probably. So sorry. GTK will never work on your platform. It's probably an embedded platform, an embedded like microcontroller anyway. So, whatevs. But yeah. So we add a little bit of padding here. So like we add 8 pointers of padding. So if we want to add a new function pointer, we do something like this, blah. Here, and then we remove 1 slot from the padding, and so on until we reach padding 1 and padding 0. So basically when we eliminate the last slot, then you remove the padding, but at that point you cannot change anything anymore. The only thing you can do is bumping up the major version of your library and then starting from scratch. This was the reason why we went from GTK2 to GTK3. Well, was one of the reasons we went from GTK2 to GTK3. Yeah, we had 2 reasons to do that. The first one was a lot of our widgets had a lot of fields inside the public instance structure, which meant people could literally poke at the internals of a widget like for free. Not good at all. And the other reason why GTK widget was down, I think, to 2 slots, probably 1, I think, if I remember correctly. It's been 14 years, so I honestly don't remember that well. But yeah, we were down to 2 free slots in the class structure, and we had to add a couple of additional new features to GTK widget that required a bunch of function pointers inside the class structure. So we had to bump the API. Otherwise, would have been nasty, like GTK widget class extra, and then you would have add like stuff class extra. I don't know, get preferred width or height. That would have been so jank. It's not even funny. But yeah, if you declare the derivable type, then you have this. And if you have instead decide to use a final type, then you don't have anything, because the macro will not declare my awesome widget, the instance structure, at all. It's up to you to declare it, but it will define the class as this. And that's it. You cannot add anything to that, because you cannot derive the type, so you cannot override the function pointers, and so on and so forth. So, final type, a derivable type will declare the instance structure for you, and it will leave you to define the class structure, because that's where the derivability like works. The final type macro will not define the instance structure, because that will be hidden in your source code, in your source file, and it will define a class structure that only contains the class of your parent. Hi Taj, do you recommend people working on No, thank you. Okay. So, where were we? Right. Yeah, are we going for a final type or derivable type? Let's go with a final type. So we have a final type, in which case OP basic H, in which case we have to use this G-define final type, which is new in GObject 270 or 72, I don't remember. But basically what this does is instead of passing 0 to the flags, so when you do gtype register static simple, at the end I use 0 for the flags argument. Let me see if I can go here. Right, gtype flags, the last argument is here. I used 0. Instead of doing that, it will use gtype 1. That's it. Gtype final is a new flag that I introduced in GObject, well, in gtype, that basically says if you try to derive from this type, so if you try to register a new type that inherits from my type awesome widget, gtype register static will fail. It will just say you cannot inherit from this type. This type is final. There is no way for you to do this. So if you use gdeclare final type in your header, in your source file, use gdefine final type. That's it. Really, it's a yeah, it's the source equivalent of the macro in your header file. Okay, it's a final type, so we need to do define our own instance structure. But since it's defined inside the source file, it will not be visible to anybody else outside of the project, outside of this file, actually, but yeah. So whenever you do gdeclare final type, the instance structure is going to be visible to you and you alone. Which means we can add stuff here. There we go. And at this point, you don't have to care about any ABI or anything, because nobody will be able to derive from my awesome widget. The structure is private. The structure is visible only to this file. So we added this field here, and we want to expose this property to other to callers or people that created this widget here. In order to do that, we have to use GObject, not GProperty and not GObject property. We need to use properties and the GObject integration for properties. And this is where things get messy. This is part of the API that I personally dislike to such an extent that I've been trying for the past 12 years, 10 years, 12 years. I've been trying to remove it. Well, I've been trying to fix it, and it's not easy. Let me tell you that. But yeah. We start with a simple enumeration here. And we call it prop_rest here. And then we do and so this is convenient mostly because we cannot use 0 for internal reason. So we start with prop rest, and then nprops is the number of properties that are going to be used by this class, that are going to be defined by this class. And then we store the property definitions inside this array that is global to the type. What is a gparm spec is... So do you remember when I said gtype instances are weird and should never be used? Gparm spec is a gtype instance. It's not a GObject. It's a typed instance, so it's something that can be derived, but it's also something that has its own type hierarchy that exists completely separate from GObject. And it describes what a property is in this case. In reality, gparm spec is a little bit more complicated and at the same time a little bit simpler than this, because a gparm spec is a way to validate values. It's yucky. It's a yucky part of the API that is the way it is. Sorry, the reason why it is done this way and not in a way that is, sensible or, nice, it's because of architectural decisions that were made at the time when the type system was moved from GTK and into glib. So early in the stream I said glib was part of GTK and the type system was also part of GTK. Turns out that people that want to use a type system for C do not really like depending on entire GUI toolkit. So you had the weirdness of having things like GStreamer having to depend on GTK, or libsoup, which is the HTTP library, depending on GTK. It's bonkers. It didn't make any sense whatsoever. So one of the things that happened between GTK1 and GTK2 was that the type system and the entire lower layer of the C utility API, which was glib at the time, was moved out of GTK and into its own project. Glib was moved out of GTK a little bit earlier than that, but for the sake of argument, let's describe it that way. So glib was moved out, GObject, and the type system, which would be called GObject, was moved out of GTK and into glib. And the main author of the GObject type system, Tim Yannick, was also a C++ developer, and he was writing a complicated C++ application. I think was what was it called? It was called Beast, and it wasn't signal processing. It was like music, like synth, was modular synthesizers, something like that. I honestly never played with it, and it didn't use GTK to draw its stuff, to draw its UI. It was written in C++ and had its own canvas UI toolkit. But since it was C++ and it was 1997, 1998, the overall idea was, let's use the same type system that we are writing in C. we are going to use it in our C++ application. That's 1999 at this point, something like that. So the type system was moved there, which meant that a bunch of requirements, a bunch of stuff, a bunch of API, some of the design was changed in the type system, or was created in the type system in order to allow a completely separate type hierarchy, a completely separate set of functionality that meant implementing a C++ toolkit for a C++ application, and then also GTK. And yeah, that was kind of messy. And we are stringing along some of the decisions that were made at the time. We are still stringing them along to this day, mostly because nobody expected glib and GObject to be this successful. And I say successful in a sense of creating a new version of glib and GObject at this point in time would be such a massive undertaking and would break so much existing code that nobody's actively thinking about it. It's an idea. We would like to have a new version of GObject. We would like to have a new version of glib to improve the type system, make it faster, make it easier to implement the new things, and so on and so forth. In practice, doing so would be such a massive undertaking in terms of scale of breakage that nobody is willing to commit to it. It is folly. Not even with 1,000 man would do that. You cannot just break GObject API. So this is the reason why some of the stuff in GObject is iffy. This is the reason why some of the stuff in GObject is slow and it's hard to fix, and changes happen so glacially slow, because we have 20 plus years of backward compatibility to maintain, and we cannot break it, because the moment you break it, it's the moment your entire OS comes crashing down, and nobody wants to commit to that particular work of cleaning it up. So yeah. So what are GParm specs? They were a mistake. In retrospect, they were a mistake. This is what we get. But in this particular context, GParm specs are descriptions of properties. They contain the metadata about a property. So in this case, we have a gboolean here, which means that we do this: object properties prop rest is equal to gparam spec bool. This is the name. These are string fields that nobody should set. The default value, which is going to be false. And then we want this to be a read-write property. GParm strings and GParm explicit notify. So we have defined our new press property here. save it for GTK 7. Yeah, see, it would be easy to say, okay, we're gonna do like GTK 6, GTK 7 in like 15 years. It's gonna be fine. We're gonna have an entire new type system and so on and so forth. And it's not enough. The main problem is we moved GObject to the bottom of our stack. And turns out that a lot of people are using the bottom of our stack. People that do not even use GTK. So GStreamer, suddenly if we bumped up GObject version, GStreamer would have to bump up their version. So we would need like GStreamer 2. And then libsoup will need a new version. WebKit will need a new major version. Everything that uses glib would need to have their major version bumped up as well. It's going to be such a massive undertaking that nobody is going to do it. And even if we said, okay, in like, we are gonna do this in 5 years. You have 5 years to deal with it. Do you know how many projects are still using GTK2? And GTK2 was done 11 years ago. There are still people using GTK2. There are still people using GTK1. Which is ridiculous. Luckily, most of the Linux distributions removed GTK1 from their basic like installation and repositories, but still there are people like very much in love with the GTK1 aesthetic. So, yeah, even if we said, okay, you have 5 years to deal with it, we will still need to maintain GObject for the next 20 years. And I don't know you, but in 20 years, I would like to not be working on GObject. So yeah, it's going to be fun. I don't know. Maybe at some point we will do this, but okay. So we created our object property, right? So we need to now we need to set it and get it, because the property is defined as being readable and writable. So we have here GObject, the GObject class structure has two virtual functions for dealing with properties. The first one is set property, and the other one is get property. Pretty self-explanatory here. And then we need to tell the class, hey, I have a bunch of properties here to install. So GObject class it's basically just, hey, install the properties, install the n properties here that are stored inside this array here for this class. What this function does is awful, and I will not speak of it. It just installs the property definitions. So at this point, whenever you, well, not you particularly, but like a language binding or whatever else, will query, does this property exist for this type? After this call here, it will. it will return if you do something like this, like will be something like this. That's cool. Rest. Okay. Class. And there you go. This is guaranteed by GObject. This is guaranteed by the fact that when you call this function here, it will take a reference on the gparam spec you just created here, and it will store it somewhere I'm not at liberty to discuss. And if you ask for it by name, then it will return a pointer to this here, this array here. This function here will also do some validation for you. So if you defined a property that is readable, you have to have overridden the get property function here. Otherwise, GObject class install properties will emit a critical warning and will bail out. Same thing, if you define the property as being writable, then you have to provide a set property function here. If you didn't do it, you get a warning, everything will bail out, and you will have to go and fix your code. These functions are your garden variety virtual functions. The object. Type. And same thing for the get property here. So set property will take a value and will store it somewhere inside your widget, inside your object class, inside your object. Get property will do the exact opposite. Will take something from your instance or your class or whatever, it doesn't matter, and it will store it inside the G value here. This pair function will be called for every single property that is set and get. So it's a single entry point, which means that you will need to do a switch on the property identifier here. So set property is going to be let's say my awesome widget set rest. So the implementation of the set property will call, in this case, the public function that sets the property. So we can declare it here as void and it will call it using the gValue get boolean. So this is kind of iffy here. GValue is an opaque container for data. Data that has a G type associated to it. So the way a GValue is defined is pretty much like this. It's a discriminated union. So it's G type, value type, and then has a union as like int, long, char, then there's a bunch of other things like GObject. So as I said, it's a discriminated union. It has a value type, the value type, which is the type that is being used to initialize the value, like value equals value init. Well, this one is literally like this. Value init. Value. This case is going to be G type boolean, and then G value set boolean, something like this. So we initialize the G value here with G type boolean, which we'll initialize here, and then everything will be like a switch. It's not exactly like this because you cannot really switch on the value type. You have to do an actual type check, but for sake of argument, it's pretty much like this. And then basically just let's re-implement GValue set boolean. This is going to be G type boolean. It's going to be value data v boolean. Right. So this is how GValue set boolean is implemented, pretty much. And what GValue is. GValue is a discriminated union that contains all the possible values that can be represented by the GObject type system. So booleans, integers, sized integers, something like this, objects, strings, doubles, and so on and so forth. This is needed because, of course, you cannot, if you have a single entry point for setting a property here and for getting a property here, you cannot pass the direct value out of the structure, for instance, for obvious reasons. The API is the API. You cannot have all the possible values as a argument here. So you need to have a container type, which in this case is GValue, and the container type is discriminated using the value inside the container type is discriminated using the G type of the data that you're going to contain or you're going to pass. So this is pretty, again, this is a C limitation. We don't have generics, so we have to it's like, mom, I want generics. We have generics at home. The generics at home. GValue. This is kind of the meme. But yeah, basically for every property at this point, we have to have a case for using the property ID. And the property ID is the index inside the array for that we pass to GObject class install properties. And the 0th element, so prop 0 for instance, is reserved. So that's why our enumeration here starts at 1. It cannot start at 0 because 0 is used as a indicator of the fact that the gparm spec has not been added to a class. Again, this is kind of the result of some of the design decision that happened when all this stuff was added to GObject. We are still dealing with those almost 2 decades later. Sadly, this is what we get. Most GObject code will also have this. The class GObject warn invalid property ID, and it's going to be GObject property ID spec. Personally, I don't like it, so I use it because best practices and all that. I personally don't find it relevant or necessary. If this happened, so if we received this kind of if my awesome widget set property was called with the wrong property ID that didn't match anything inside our property array, things would be so broken that emitting a warning is kind of the laziest way to deal with this. Things would break long before that happened. So honestly, yeah, it's fine, but I don't think it's as required as when the Earth was young and dinosaurs roamed around and GObject was very new. These days, again, if this happened, it means your code is completely fucked. And if it's completely fucked, then at that point, warning. GAssert no reach, it's basically the same thing. GObject warn invalid property is pretty much GAssert no reach without the abort. It's just a warning. At that point, yeah, it's just a critical warning. But I've never ever seen anything like this. Like, I've never seen this warning happen except in very synthetic cases, like for unit testing. In actual code in the wild, no, never. So we have the set property and we have the get property. The get property is dual of the set property. So instead of getting the value from getting the Boolean value from the G value and setting it on our awesome widget, we are taking the value from our awesome widget and setting it inside the G value. That's it. That's all there is to it. There's nothing else. Of course, you can play around with it. For instance, if you have a complicated property like I don't know, props computed name, and it's a string. Doesn't have any default value, and it's read-only like this. Yeah. And yeah, it's read-only like this, and it doesn't exist inside the structure, so it's going to be something like case computed name and it's going to be G value set string or like big string, and it's going to be my awesome widget compute name. Then yeah, basically you're not passing like a value from your instance structure, you're passing a value that is being computed by a function. And at that point, yeah, that is how properties can also be used. So you don't actually need to have everything. When you define a property, you don't need to have the property stored inside the instance structure. It can be computed at runtime as well. Especially for read-only properties like this, not having to store them is perfectly fine. But yeah, again, read-write is one option, readable is another option. You can also have write-only properties, so properties that you can only set and you cannot ever get back. They're more useful than you'd think, but there are cases where that happens to be the best option you have. You set a property and that property gets, I don't know, appended somewhere. For instance, yeah, let's say you have, I don't know, CSS classes. Another string, and you go CSS classes. And it's write only, right? So write only means that only has a set property here. And it's like self, business classes, well, the pointer array append the value, yeah, string, dot string, so you can only write to it, but when you write to it, what happens is that the value gets appended to an array. If we wanted to make it like read and write, then it would not be a string, it would be a string array instead of being a string. I don't, strictly speaking, from a like best practices perspective, I do not really recommend doing this. If you have a property that has a type, you should have a type in both directions. So if you have a CSS classes here, it would be easier to have a CSS classes that takes a string vector and then returns a string vector. And then you do the appending, and you do the appending yourself in your caller code. But if you have something like this, it works. GTK3, the GTK container in GTK3 had the child property that was write only, and it was essentially a shortcut for doing the container add for adding a child using GObject set. And you could call like GObject set multiple times and it would append the child or add the child to the widget. And it was write only, because you cannot query a single child. So you cannot do GObject get like container child, because containers may have more than one child, first of all. So you cannot return a single widget if a container has like a million of them. So that was the child property was a write-only property for that reason. Again, I don't recommend it in newly written code. It's not great. If you have a property that is readable, well, if you have a property that is writable, you probably want a readable version of it as well, and they should have the same type. Pretty much. So the last bit of properties is the setter is now calling the public API here, my awesome widget set pressed. How do we implement that? Well, we implement that as my awesome widget set pressed. And the simplest way of doing this is, well, first of all, we have to do pressed equals pressed, because C sucks. And then we do if, fuck's sake. If self pressed not equals pressed, then we do self pressed equals pressed. Then we do GPK widget graph, for instance. And then we do GObject notify by vspec self pressed. So what are we doing here? Well, first of all, gboolean is not a boolean. Gboolean is an unsigned integer. It's an assigned integer, an integer. Doubt. Press X for doubt. It is glib types. Where are you? It's an integer. It's a signed integer. Ignore a bunch of this stuff. It doesn't exist. It doesn't exist. Like, don't look at it. Don't look at it. It doesn't exist. But yeah. So, gboolean is not a boolean. Is an integer. So it's a wide int. It's a 32-bit integer. This means that anything that is not 0 is a true value. Which is fine. It's C. It sucks. We know. The main problem is some people might decide to store booleans as bit fields. Like this. You impressed 1 bit. Because it's a boolean, right? You only need 1 bit. You don't need anything more than that. Okay. Now, what do you think happens when you store like 42 inside a 1-bit bit field? What happens is things go to hell. It will probably be 0 because it will try to store like 42 in binary. more than that. So, hi, Alatira. Gboolean predates bool by years, which is fascinating. Yes, it is. It predates the bool in C99 by about 3 to 4 years. At the time, there was C89, so nothing else. Which means bool didn't exist. It existed in C++, but of course also C++ was pretty much unspecified. The first real C++ specification is C++11. Hard to like wrap your head around it, but yeah. The first real, well, there is a real C++ like ages before, but it's still the first real revision of C++ is C++11. But yeah, bool didn't exist at the time, so everyone implemented their own version of Boolean, just like everyone implements their own version of a string in C++, which means that Boolean was a full integer. Why a full integer instead of a short or a char? The reason is lost to time. Apparently there were architectures in which using a full integer was more efficient than using a short integer or a char, so using a byte. What those architectures were is unknown. Those architectures may as well be called Voldemort, because nobody can tell the name. The end result is that Gboolean is a full integer, which means that if you want to store it inside a bit field here, you have to do this. You have to negate it twice, so that this will be either negated to 0 and then not negated to not 0, which means it will be negated to 1. It will be 1, and which point it can be stored inside a bit field. Or if you don't want to waste time with this bullshit, you do this and you take the hit. It's gonna be an integer anyway. So C is perfectly in the C compiler is perfectly in its rights to change the way this whole thing works. It doesn't matter. So it only matters if you have a structure that you are going to serialize to some place, and the size of every single field matters, and you have to do things like packing bits so that you can take it and serialize it on the wire and do things with it. For instance, that is the only reason why you would do this. Everything else is premature optimization, and unless you are also checking how the structure is packed together, you shouldn't bother with that. Just do that. Still, it's a good idea to do the Boolean conversion here on your arguments, so that people that call my awesome widget set pressed widget, and I don't know, value, and value is int value equals 42. They will be satisfied anyway. After that, we call a method on GTK widget. It's entirely unimportant what it is, doesn't matter. And then we do the last bit of writing a setter function. GObject properties have the ability to notify of changes. So whenever you change a GObject property, you should, if the property is readable, you should take it and emit a notification on that property. In this case, since we have access to the gparam spec because we store it inside our array, global array. We use GObject notify by pspec. Otherwise, if you don't have it, you can do GObject notify you can use the name of the property here. This one is slower, so try not to use it. There's a reason why we store the gparam spec in a global array here. It's because then all the property notification stuff is easier to deal with. It's faster as well. What does GObject notify do? It will emit a signal on GObject. It will emit the GObject notify signal. As I said, we are probably not going to be talking about signals today because signals are a lot more complicated than properties. And also we will probably talk about the construction and destruction sequences of GObject in the next stream. So that you don't get overwhelmed by a ton of stuff. But I'm planning on doing that. So probably next stream is going to be creation and destruction, and if we have time, also signals. Because signals imply the description of closures and marshallers and a bunch of other things that are going to make your brain bleed through your ears. But yeah, suffices to say that GObject notify by pspec will emit a signal, will emit the notify signal on GObject. And you can then connect to that signal from outside of the object to know if a property was changed. And changing properties are interesting because they allow us to do things like model view splits. So you have a state object that contains all the state that you have, and you have a view widget that displays the state. And then you bind the property on the state object to the view widget, and then you keep those two objects in sync. So whenever the state changes, the view changes as well. If the connection is bidirectional, then every time the view changes, like the view gets modified, then the state also gets modified. Or in the case of having a controller object, then you create a binding between the controller and the state, so that goes in the other direction. Instead of going from the state to the controller, goes from the controller to the state. But it allows you to create user interfaces and any other kind of application code that is using the model view controller design pattern. The reason why, so this is the C API, the public C API. It's not strictly speaking necessary to have your set property call the public C API. It could also do something like this. You can directly set the value on the instance. The reason why it works that way, it's because when you call my awesome widget set pressed, the public API, you are directly manipulating this function here. You're directly manipulating state from here. This function, the set property function and the get property function, they get called not by the C API. They get called by the GObject API itself. So GObject set will end up calling my awesome widget set property. And also GObject new will call this function here. So it's the generic API that calls the set property and get property API, the virtual functions. And who calls these functions here? If you're using C, you should never really call GObject set. And GObject new, you call it implicitly whenever you call the constructor here, but you should never set the properties using GObject set or GObject get, or well, GObject set property, or any other variant of that, because that is going to be slow, because they have to take your true value here, pack it inside a G value, then pass the G value to your function here, unpack it, and then call, for instance, the C API or not, but it's fine. So if you're a C developer that is using this API, you will not call this. But if you're a language developer, if you're a language binding user, so if you're using this API in other languages, then every time you set pressed or you get pressed, for instance, in Python, it's going to be like widget props pressed. This will call my awesome widget set property. So this is going to be used by language bindings, for instance. Another thing that will call this function is if you are writing XML in your awesome widget, like object class, my awesome widget. So if you're using GTK Builder, that is also what will happen. It will call GObject set. So this API is needed for when you use the generic GObject API. But having two separate places where that happens is kind of a lame thing to do, mostly because it can be complicated. For instance, we now are calling GTK widget draw here. So at this point, we need to also call GTK widget draw. And it gets more complicated if we start doing more validation, for instance, or doing a bunch of other like side effects for this when setting this property. At that point, why are you replicating the code? Why are you repeating yourself? Might as well call the public API. There is a snag. There is a snag because the public API calls GObject notify, but GObject set also calls GObject notify on the property that you are setting. It will do that automatically. This is needed because in the past, people did repeat themselves. So the set property would call a bunch of API without calling the public API. At which point, the GObject notify would not be emitted and the setter function would not be valid. So the setter function would not notify of a change. And that is bad. So as a fallback, GObject set always emits the GObject notify. That is unavoidable, sadly, except we made it avoidable. For a long while, it was unavoidable. So GObject has a way to compress the notification. So if you emit if you call multiple notify by GObject notify, like for the same property, it will emit them once instead of emitting like 25 of them. If you need to freeze and thaw the notification queue, but for the sake of argument, if you have duplicate GObject notify calls in the same object. They will usually be compressed to one. But it still is a lot of work that you have to do, and it's pointless to do it. So one thing that was added to the param spec flags was the explicit notify. If your set property is calling the C API, the public C API, or the private C API, it's fine. If it's calling C API, it's not modifying the storage directly, but it's calling another function and that function will call GObject notify, then GObject set will not call GObject notify for you. The notify will be explicit and will be part of your own API. So again, this is a way to undo some of the decisions that were made, but it has to be opt-in. It cannot be opt-out because API and API compatibility concerns. But yeah, if you have API that sets the property because you're supposed to call that function, for instance, or because it does more than just setting a field and then notifying emitting the notify signal, then always remember to use explicit notify on the gparm spec that you're creating, so that you will only notify once instead of notifying multiple times. And pretty much this is all there is to it for properties. There is not much else, actually. So the last bit is about construction. So construct properties and construct only properties. But in order to discuss construction only properties or construction properties, we will have to discuss how to construct and then how to destruct object type. And I think that is going to be the topic for the next deep dive into GObject. At this point, I hope I'll be able to do it on Monday. So it will be, it will be another deep dive. In that case, we're going to go straight into how objects are allocated in memory, how their size is computed, private data structures, both on the instance and the class structures, and how to, why GObject has two destructors instead of one, and then reference counting and a bunch of other things there. But yeah, it's going to be another interesting deep dive. I say it's going to be another interesting deep dive. It's going to be interesting for me, mostly because I know this stuff, but it's interesting to talk about it. I don't know if it's going to be interesting for you. I'm just going to be talking about it. But yeah, if you find this stuff interesting, then feel free to subscribe to my Twitch account so you get notified every time I start streaming. Otherwise, I think I'll have to do an outro at this point, or not. I'll probably try and compress all of this stuff into a single video at this point, instead of doing like the VOD for YouTube. Well, I'll do the VOD for YouTube as well, because people have been curious about this stuff, but I'll try to take the VOD of each stream and then compress it down into something that is going to be useful for people that don't have 9 hours of their time to listen to me describe how GObject works. But a quick outro for the YouTube crowd, and then we'll see what happens. if you are interested in understanding how the GNOME development platform works and how it's put together and how the basic C libraries that compose the GNOME software development platform work together, then why not subscribe to my YouTube channel? Otherwise, if you follow me on Twitch, twitch.tv/abasi, you can get notified when I start streaming about this. And then that's it. Yeah, on Monday we'll go through the construction and destruction. We'll figure out how everything is put together and then deallocated, so that people can understand stuff like reference cycles, understand how to couple and decouple objects together, and then we'll see how that deals with things like properties passed to the constructor, and how to deal with default values and things like that. So hopefully it will be interesting for people that are still, they don't really know much about GObject, but also people that are still fuzzy on how GObjects get constructed and destructed, which is a complicated topic at times, but it's kind of fundamental if you don't want to leak stuff all over the factory floor, or if you don't want to get weird memory corruption bugs. But yeah, hopefully will be interesting for everyone else. If you're still here, thank you very much for following along. I hope it was interesting, and I will endeavor to make it interesting next week when we talk about object construction and destruction. Have a great rest of your day, have a great Friday, have a great weekend, and I shall see you all on Monday. Bye.